And to Let's Start Talk Chemistry with Pastor Dan. We're looking today at conversion practices. Conversion practices. We're looking at conversion of unit conversion, dimensional analysis, factor label like we did yesterday, as well as scientific notation. So there's a practice that I pulled up my class. Now, it's a little weird here, so let's make that over there. Copy those down. I did get rid of one problem when I did it with my class because it's just taking a little too long. Copy that, or you can pull the link up that I have inside of there. All right. I thought it hurts me knocking. All right. Now let's get started with the practice. Oh, what am I doing here? All right. So let's go forward here. Now, also make sure that you have these conversions. These are the conversions that I gave to you before. You can again download those or copy those in some way, so that way you have all the ones that you would possibly need to work with. All right, so that being done, let's take a look at one of the problems I gave you. I said they had to 38.250 ounces, and I want to know how many cubic centimeters that is. Now, in order to do that, according to the process, let's say we take the given over 1, and that's what we do. Then we look at that list I gave you. We know that ounces goes to cups. So 8 ounces is 1 cup. Look at that list also. You can say that cups goes to quarts. Look at that list again. You see quarts goes to liters. Look at that list again. We see liters go to milliliters. And one last time we see that milliliters goes to cubic centimeters. Now we use these equalities in order to make a converter, or a fraction. Cross out what we're in and getting what we want. So we're going to start with this first one. 8 ounces is 1 cup. Ounces have to go on the bottom. So we're going to put 1 cup over 8 ounces. We do that so that the ounces cross out and we're in cups. So now we're in cups. This number hasn't changed, just the value of the units has. We then look at the second equality. We said that 1 cup is 4 quarts. We did that again so that cups cross out and we're in quarts. All right, we're going to finish the rest of them then. We're going to say that 1 liter over 1.06 quarts, 1,000 milliliters over 1 liter, and 1 cubic centimeter over 1 milliliter. Now, ounces cross out, cups cross out, quarts cross out, liters cross out, milliliters cross out. We're left with cubic centimeters here. It's our units. So taking your calculator, type in 38.250 times 1,000. We don't have to multiply by 1 because we know what that means. Hit equal, divide by 8. Each time we do this, we want to hit equal, so hit equal, divide by 4, hit equal, divide by 1.06. When you do that, you get an answer of 1,127.653302 cubic centimeters. Now we have to remember sig figs. All of these equalities are infinitely significant, so we don't look at any of these. We just look at this one over here. I have 5 sig figs. The 3's not 0. The 8's not 0. 2's not 0. 5's not 0. The 0 is, but it's after a number and after a decimal. It's showing exactness. So I have 5 sig figs. Answer is 1,127.7. That's 6. The number next to it to 5 rounds up to a 7. We're good to go. All right, so let's look at conversions. Now I'm giving you a number here in scientific notation, and I want it in regular notation. So we're going to write the number down as it is. So that would be 7809000. Now this is to the 6. It's positive. We're going to go this way 6 places. 1, 2, 3, 4, 5, 6. So we get that number. The problem, though, we've got 1, 2, 3, 4, 5, 6, 7 sig figs. These 3 zeros are significant because they're after a number, after a decimal. They're significant, so I have to put a bar there to make that significant. All right, let's try going with a negative exponent. Let's say I give you 9.4500 times 10 to the minus 5th. All right, let's put a number down, 94500. It's negative, so instead of going to the right, we're going to go to the left. Going to the left 5 places, so we get 0.000094500. Those 2 zeros remain because they're significant here, so you have to be significant here. That's what 9.4500 times 10 minus 5th is as regular notation. All right, let's try going the opposite way. This time I give you 0.0003450. Base number, 0.3450. All right, now, how many places do we move it? We moved from here to here. 1, 2, 3, 4. So it's going to be times 10 to the minus 4th. This 0 here remains because it's significant here, has to be significant here. Let's try this one here. Hey, look at this here. You go, wait a minute, what's that line below there? The reason why I had to put the line in the practice there is because I couldn't, when I tried to put it in there, it didn't fit up. It actually means that. It's supposed to be on top there. So put our base number down, 1.3567. And I only list those 3 zeros because that's as far as we go. How many places do we move it? We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 places times 10 to the 10th. I have to have those 3 zeros in because these are significant here. These are important but not significant here. That's what we get for an answer. All right, so here's the answer sets. And I did have an extra problem in there that I crossed out, so that way it's not quite as long. Again, I will post those into the comments so that way you have them. Hopefully that wasn't too bad. I'm a little bit busy right now, so I'm not going to get a chance to talk to you a little bit afterwards. We'll talk tomorrow when we got more practice. Take care. Be good.